Hello everyone and welcome to Great Learning. My name is Anugrah and today we will be discussing on the topic transformation in the FMCG industry through data science. And we have two of the pioneers in this field with us today. Our first panel member is Kshtij Mathur, who is working as Senior Manager, Data Science and Analytics at Diageo. And he specializes in consumer marketing, digital marketing, and commerce and finance in Diageo. And our second panel member is Shashank Singh, who is also a senior manager data science and analytics in Diageo and specializes in supply chain management field. So please feel free to post your queries in the chat window and we'll be taking up all the questions that will be specific to this particular topic of discussion. And so without any further ado, let's start with the discussion. Over to you, Shashank.
Thanks, Anugrah. So, Kshitij, if you can just go to next slide. Hi, everyone. So, um, I'm Shashank. I'm currently working with Diageo for around 3 years now. And overall, I have 13 plus of years of experience where, in my current role, I lead the global advanced analytics agenda for Diageo in the area of consumer marketing, digital marketing, and digital commerce and finance for Diageo. And in my past, I have worked as a consultant for Government of India in their Aadhaar program, where I have designed their AI/ML based fraud analytics tech stack from scratch. And prior to that, I used to work with Subex. It's a product company in the area of telecom fraud analytics and revenue assurance, where I helped the telcos across Europe, Middle East, and Africa to fight fraud and prevent revenue leakages otherwise. So education wise, I have a bachelor's in electronics and communication engineering from Uttar Pradesh Technical University, and I'm also certified from Big Data Analytics program of Indian Institute of Management, Bangalore. And outside of work, like I love cooking, and I'm a great foodie and a fitness enthusiast. So that's about me. You'd like to introduce yourself, Kshitij?
Hi everyone, I'm Kshitij. I have 13 plus years of supply chain data science experience. In my past, I have worked and led different kinds of an optimization problems in the manufacturing, healthcare, avionics. From education wise, I have done my MBA in supply chain with engineering computer science. I am Apex BSCM supply chain certified with Six Sigma certification and statistical quality certification from Indian Statistical Institute. Outside of my work, I love reading detective novels. Over to you, Shashank.
Thank you, Kshitij. So yeah, so how we have designed this session today is like, we'll give you an introduction. I mean, after our introduction, we'll help you understand like from the very basics, like how does a consumer product group companies or an FMCG organization work, and then what are the some of the areas where data science can help to create a strategic impact. And then like we take up two problems, one from consumer marketing side and one from supply chain side. So where we'll first understand like how we model the problem, and then how we approach and use data science algorithms to crack that problem and how the results look. And then I'll then hand it over to Kshitij, who will take you through through some use cases in supply chain, where he'll give you some basics on how does how you can optimize some manufacturing processes, how you can digitalize those processes, and some potential ideas around then. And then he'll take you through a use case on throughput optimization, and we finally close the session with some takeaways on how to succeed as a data scientist. What does it take to create from create an impact in the business, from an from an academic perspective and from an industry perspective. So let's begin. Kshitij, next slide please. Okay, so I'm a foodie, so I'll take an example of any kind of a food or a drink, so and then we'll take, let's say, uh, I own a CPG company where I produce, snacks, and my snacks are like really, really famous, and I have a really good, you know, sales and things like that. Now, to run all of it in a as a well-oiled machinery, how do I begin? I begin from collecting basic raw materials for my snacks, and I'll manufacture them into finished products. Now, once they are manufactured, I need to, send it out to my distributors. Need to plan my logistics and inventory accordingly, to make sure that my distributors never run out of stock, and also, my products are as fresh as possible. Not reaching an expiry date. And then again, from the distributor's perspective, I'll also make sure that they are out in the retailers, in the and in the retailers, I have the right product for the right audience. And then the consumers, like you, me, or anyone here, like they get the right product at the right price at the right time. Okay. So in all of these steps, if you look at, there is data science, some sort of data science involved, in one form or the other. And uh, you know um, after, like, probably telecom and banking, FMCG is an industry which is pioneering the use of data science in solving their business problems, and one of the early adopters to embrace these technological changes and create an impact. Next slide, please. Okay. So, like, what are the some of the areas, where in that entire, from manufacturing to final consumer, where data science can create an impact. So, I mean, this is not an exhaustive list, but these are some of the use cases where, we can use the data science techniques to create an impact. So something like, how the market, how I can preemptively track my market evolution altogether, and my company's category of products, how they are fitting in that evolution. And using that evolution, how can I preemptively improve my consumer experience, okay, through these evolution tracking. If I have, and like nowadays, a lot, I mean, almost every big CPG has some sort of an online or e-commerce presence. Okay. So now, how do I improve my, even, and apart from the offline brick and mortar retail stores, so how do I improve the footfall or traffic at my retail outlets or my e-commerce outlets or things like that. And we also, as a CPG companies, we also indulge in a lot of advertisement and promotion. So how do I improve, my campaign response time, my campaign ROI, you know those sort of things, in at the store level or at an offline and online store. How do I optimize my inventory by predicting my demand, and keeping, so that I never run out of any stock, never run into any stock out situation. And again, from a manufacturing process, which Kshitij will talk about in more details, is like, how do I optimize those processes in my factories by probably reducing some unplanned downtimes through predictive maintenance or some throughput optimization and things like that. So next slide, please, Kshitij. Okay, so now let's pick up one of the subset of the problem. So out of all the potential, I mean, some of the potential use cases, let's pick up one of the use case and try to solve that. So, but before solving, as a data scientist, a very important thing is, like, you first understand and model the problem first. So a lot of people, when they see a problem, they just jump into, you know I should apply this algorithm, I should apply that. But no, that's not a very good approach. What I would suggest is first you understand and then model the problem first, rather than modeling the solution. Now, the problem that we pick up here is, like, let's say, I want, as a business, I want to understand how consumers are interacting with our category of products, and is there some latent trend that I can detect from that interaction, and can I identify some sort of a taste and preference polarity for my consumers. So how do I go about solving this problem? So this is basically, I'm trying to track the market and the consumer evolution for my category of products. Okay. Now, before we begin any data science, how do the first thing is, where do I get my data from? So one of the good platforms, to acquire this data would be any social or digital platforms, where, because a lot of people nowadays are like online. So one of the ways, market research, and then there's this new age way where we can, um, understand through some organic conversations on the social and the digital platforms, like how people are, interacting with my category of products. So now, once I have identified the data sources, like there are like some immediate steps and intermediate steps involved in cleansing and harmonizing and parsing the data. But let's say we have done all that, and we have a pertinent question. What kind of algorithm should I use to um, understand, this answer these questions? So should it be, I mean, is it a supervised learning problem or an unsupervised learning problem? So let's say, I mean, this is because I do not know anything, and I want to understand what people are talking about. So it's clearly an unsupervised learning problem. Now, the moment it is unsupervised learning problem, people will jump, okay, should I do a clustering? Should I do a topic modeling? What should I do? You know, so we understand, okay, clustering is something where you clusters things based on the similarity metric. But topic modeling is something where it's a generative kind of an effort, where you try to understand the themes through some generative probabilistic model, to understand what were those underlying themes, and what are those uh, because there is an inherent thing that similar words occur under similar contexts. Okay. Now, so let's say we choose topic modeling, and then we are data scientists, so we do a lot of reading and learning. Okay. So should I, which of, so let's say you did some Google search, and to understand like what are the various topic modeling algorithms, and you probably figured out, okay, LDA is probably the best state of art latent distillate algorithm is state of art available. Now, should I, another pertinent question, should I apply or should I learn the algorithm first and then apply, or should I apply and then learn? So in the sense, like, if you do not read about how the algorithm works and you apply it directly, that's going to be a truly unsupervised learning algorithm. Okay. So we need to understand first, apply, and then iteratively kind of improve. That's how any data scientist approaches a problem. Okay, next slide, please. So now we picked up latent distillate algorithm, and that's a probabilistic algorithm. So I'll just spend few seconds on refreshing a bit of a probability distribution concepts here. So there are a couple of them, like a Bernoulli distribution, which is nothing but a coin toss. So where we there are two outcomes, and we just need to estimate one parameter. It's either heads or tail probability. And then there are like categorical or multinomial distribution. The example of that would be draws from a, or balls from a bag. Here I need to estimate n minus 1 parameters. Why n minus 1? Because the last one would be the probability, subtracting all the probability of all the other occurrences, the last one. And then we have this distillate distribution. So what it does is, it rather generate this bag, these different bag of balls. Okay. And that's what we are trying, will try to understand, like how it helps in topic modeling. Next slide, please. So now let's understand some basics here. So uh, if we talk, the messages or the documents are nothing but a collection of themes, a collection of topics, and topics are nothing but a collection of words, or a bag of words. So we have these two parameters here, alpha and beta. It is important we remember them. We'll use them later. Okay. So the thing is, like, this is an unsupervised learning algorithm. So will put some initial seed values to alpha and beta. Okay. And alpha is nothing but a prior distribution of themes per message. Okay. And beta is nothing but a prior distribution of words per theme. Okay, next slide, please. So if I put in all of it together, what are the model, what is the model, what are the parameters, and what are the variables? So let's say there are m documents, and like they contain n words. Okay, and since it is a unsupervised learning algorithm, we will define, like, we want to discover, let's say, 3 topics or 4 topics or 5 topics from those set of documents. And as I told you, alpha and beta are like per topic distribution prior, and per topic word sorry, per document topic distribution prior, and per topic word distribution prior. So we try to estimate the topics, the words. Okay, and we have these parameters, uh, phi and theta, which is nothing but like these are the 2 parameters. So we start with the seed values of alpha and beta, and then we evolve and towards this theta and phi. These are nothing but the, the maximum likelihood probabilities which generate these messages. So next slide, please, if I just go in a bit more detail to understand. So now the thing is, like, we have this theta and phi, which were the initial, which is nothing but the probability of topic given document and probability of word given topic respectively. And so the probability of word given a document, okay, that's what the topic would be. So this is nothing but a uh, you know multiplication of these two factors, and assuming the conditional independence and rearranging these equations, we have individual this is nothing but a dot product of theta and phi. And what we have of these theta and phi matrices, and what we have to do is we have to learn the weight of these matrices. And how do we learn the weight of these matrices? We maximize the likelihood of our data, the evidence that we have given these 2 matrices. So we start at random and then try to converge towards the evidence that we have, which is nothing but our document. Okay, next slide, please. So now let's get some perspective, like how hard this problem could be. So let's assume, like, we want to understand, we have 4 themes and 10,000 messages, and we want to derive 4 themes out of it. So the theta matrix would have around 40,000 parameters, and then let's assume there are 5,000 unique words across all the messages in my corpus. Okay, and we have 4 themes. So sorry, I think there's a typo here. So we have around n minus 1 into 4, that's around 20,000 parameters. And then if we assume there are like 50 words per message, and there are 10,000 messages, so there are 500,000 word corpus. So in total, I'm trying to estimate somewhere around 560,000 parameters, which which generated these 10,000 messages. Inherently, that's a very hard problem. It's nothing but estimating a posterior joint distribution, and it's a very hard problem. But thankfully, we have something called Gibbs sampling algorithm, which can help us breeze through this. Okay, next slide, please. So now the thing is, like, we know, as we said, assuming we know the theta and phi matrices, we want to maximize the likelihood of our data given these 2 matrices. So how do we do this? We assign these theta, we create these theta and phi matrices at random based on the alpha and beta values, initial seed values of alpha and beta. And then we take one parameter at a time, keeping all the other parameters constant, improve and change those, the value of one parameter, see against the evidence again in the actual message. And once this parameter is fixed, we take next parameter, and we do this exercise for a number of iterations. So if there's a mathematical guarantee, like if you do it for a number of iterations, this is bound to converge. So let me take you through some example, like how this works. So let's say we have a message which says, like, India enters World Cup final. Okay, and we just assigned random topics here, like India, the word India is topic 1, enters at topic 3, world again as topic 1, cup is topic 2, and final is topic 4. We have a count matrix. So it's something like, in all the other messages. So let's, I had 10,000 messages, how many times India occurs, how many time enter occurs, how many word, and across different messages, across different topics, how the counts are. So this is a count matrix of the topic k across the different words. And then I also do a topic count against the against the number of documents. So I have these two. Basically, these are nothing but the theta and phi matrices that I have created at random. Okay, next slide, please. Now, what I have to do is like I just change, let's say, world from in the topic one, the count from 28 to 27, because we do not know right now where the word world belongs to which topic. Okay, and the other metrics we represent in these format, topic one, topic two, and we do a dot product. And then when we multiply these two matrices, we get our conditional probabilities, and then again we assign the random topic again, and we repeat this exercise a bunch of time, and we finally converge to a maximum likelihood probability. Okay, next slide, please. We've had a lot of maths here, but like, how do we put all of it in perspective, from the technology framework where I have to deliver the actual result? So what we do is we have some raw data sources. So let's say if I pick up the social platforms of Instagram, Twitter, Facebook, Pinterest, they have all their APIs, through which I can collect data. And once I collect the data, they are in JSON formats, and I have to store them, and then I have to normalize them to those JSON files. And once they are normalized, there I have to apply a bunch of text cleansing, uh, probably like punctuation removal, the lemmatization of the words, the POS tagging, and selecting the only required POS where I can do the topic modeling. And then once I have done this topic modeling, I know when the messages were posted, the geographies from where those messages were posted. Okay, so it's nothing but this unstructured data I have structured out into and with the topic modeling, I know what are my themes, what are my top words, and I can track their evolution over time. So I have inherently converted this unstructured data into a structured sort of time series, structured time series vector. Now when I have that, I can apply any forecasting method and forecast. So let's say I discovered a theme around let's say spicy food. Okay, and I know historical evidence I have that, okay, historically this is the seasonality, and this is how it looks in the historical time series. So when I can now forecast, like in future, like is my demand for spicy food going to go up, going down, or remain stable as it is? So that's the way I have understood the taste preference and all those evolutions. And then you finally have the visualization layer where you can show and forecast. And the one note of caution, like, social media is something where and there are things that can change inherently very fast. So I would not kind of predict for more than a year in this case, because of the inherent volatility with the these kind of trends. Okay, so next slide, please. So that's now let's say we've done for some something like, let's say I wanted to understand like how beer probably would go. So you remember the initial seed of alpha and beta. So the thing is, like, if I give and you see the difference now between the outputs when I give some very large value versus when I give some very small values. Okay, so if I give a very large value, it's a kind of a uniform distribution everywhere. So that means uh, all the topics will inherently contains almost all the words, which we do not want. We need to have a bias here where we want, like, if there are topic one. So when we reduce these these counts, okay, so that's where we get a bias. And with that introduction of bias, we are inherently able to understand that, okay, the topic one, this is more about craft beer. Okay, topic two is more about bar, party, fun, music, some on premise and loud music places with party. Topic three is more about some vacation and chilling out on vacations and things like that. And topic four is more about food and flavor associations here. So now this is how I kind of understand and use it for forecasting and things like that. So I think I've taken a bit of more time than expected. So that's all from my side. Any question?
Thank you so much, Shashank, for the wonderful discussion. So the next part of this discussion will be taken by Kshitij, and we will be discussing optimizing manufacturing in digital age. So over to you, Kshitij.
Thanks, Anugrah.
Yeah,
Sh-
just give me a minute. Over to you, Kshitij.
Thank you. So, folks, let's try to see and open the Pandora box of manufacturing and see how we can apply data science in the manufacturing processes. What we will also talk about and try to understand about industrialization 4.2, automated guided vehicle machines, computer visions, and we'll try to see what are the different use cases, what are the prerequisites for that, how do we do it, and then we will talk about a specific case which is a throughput optimization. We'll go into a basic of the mathematical, the building block, and then what is its interpretation, followed by the takeaway. Now, when you think about the manufacturing processes, this is very critical for any industry because no, Shashank, thank you. So on this slide, for ease of our understanding, I'm taking a case of a water purification. Now, what exactly is this process of the water purification? We get the raw water influx, a feed basically. We put into a system where which goes is basically a RO filter, which has a internal membranes. It does a process of RO permeation based on different temperature and pH value, and then it gives you the pure water. In addition to it, it also gives you the impure water, which is basically the wastage. Then this pure water goes to the bottling line where the filler comes, the bottles are filled, packed, labeled, checked, and then sent for the shipment. Now let's try to think about this value chain in more detail. What exactly are our processes talking about? We have the raw water, we have the pure water, we have the final product as the bottle. Now, suppose if we want to increase the efficiency of this RO purification, how do we do that? If you guys have experience at home in the RO purification, if you use X amount of water, maximum amount of the water comes out as a wastages. Now, is there any possibility? And that is what we were trying to look in from a mathematical function. Now, also let's see what are the some of the what could be the potential use cases from in manufacturing from a data science perspective. Now, imagine a scenario when this line is running and all of a sudden there is a breakdown. Breakdown could be of any breakdown could be of any reason. Could be a mechanical breakdown, electrical breakdown. It is basically it has halted the process, and this stoppage has an impact. If you think about the overall equipment effectiveness of the machine, which is basically a function of availability of the machine, quality and reliability, has gone on a toss. And OEE is having a direct impact on your P&L of the plant. Now, is there any way that we can look into this particular segment and says that, yeah, we can say and predict when this machine is going to in a breakdown state so that we can go into a plant shutdown mechanism. We can do the maintenance much in advance and we can mitigate the risk of an unplanned shutdown. Definitely, there is a possibility. So how do we do that? Let's take one more example. How do we move the liquids or solids in a plant? Solids are mostly moved using a conveyor belt and liquids are using a pump. What is the basic machine which is moving those belts or a pump? It's an electrical motor. If you think about an electrical motor, this is basically a machine which has a magnet and a coil and it rotates when you pass electricity. Now, if you think about this process, it has some kind of an physical, some kind of a mechanical and electrical components. Now, is there any way that we can understand what exactly is happening inside it? Definitely there is a way. You guys might have studied in physics about acceleration. The same thing, acceleration, we can measure it. which is basically is a kind of a vibration. So if your machine, if your motor is running in the normal phenomena, in the normal way, it has a different kind of a cycle. It has a different kind of an amplitude. And those kinds of information can be read by our probes, which is the vibration analysis probes. Once you get the data, we can build up a model is that under these circumstances, different scenarios, different compositions, permutation, combination, what is the best and the natural phenomena happening based on the different wavelets coming out from that probe. Now, think about a cold temperatures. Think about Canada. What happens if you put the same motor in Canada? It will freeze. It may not give you the same function. So there you are bringing another angle of a temperature, which is another parameter. Think about your electrical conductivity. Think about the voltages, the resistance of the wire, insulation. All these things brings you as in different parameters. So when you go in fix in, when you go into the system in your repository, you look about the data set, you have the wavelets, which talks about the distribution of the distribution of the acceleration. Then you have the temperature, you have the pressure, pH in some of the scenarios and different. Now, based on this data set, we can come up in an equation which can say is that, look, in normal phenomena, this is the equation. In an abnormal phenomena, under these circumstances, this is the equation. And guys, that equation will help us to come up in terms of the prediction. Once we know what is that equation, we can enable that in our system. All this understanding, all this calculation you can do in Python or big data. And then once you know the equation, we can configure, and the output could be either in terms of a visualization, be it Power BI or ClickSense. It could go back into your PLCs, which is the logic, the electrical component where the automatic functions can be taken. It could give you some kind of an alert to the plant managers where they can take the proactive measures. And by just a small case, or by just a small foundational block of an, if I take an example of a linear regression, you can solve this problem. And guys, you see how we are trying to link your core machine problem, your different kind of a data problem, just by using foundational mathematical equation to give you the output. Let's think about another example. On this example, think about in this bottling line, when there's so many bottles are moved, what happens? One of the bottle is punctured. What happens? One of the bottle is labeled. Can we go? Is it possible that a human sees all those bottles? Might not be. And that's where the computer vision comes into picture. So in factories, we can have the high scanner computers, which gives you so many images in different FPS. And then using our machine learning algorithms, we can read those images, we can build the different models, and we can say is that this is where the anomaly is happening, and this is where your line is running. And then we can pinpoint those specific bottles and remove it from the assembly line or from the packaging line, which is another a different case of a computer vision and linkage with a machine learning, giving you the benefit on the production line. Now let's talk about the throughput optimization, which we'll be talking about it. What exactly is it? Now in this process, let's concentrate on the RO water treatment equipment. That's the second part. In this, we are getting the raw water feed. We have this water will have some intrinsic properties, some characteristics, and then we have the machine, which is the permeable machine, and then it will give you the output, which is your pure water and the impure water. Shashank, can you please go to the second slide? Thank you. Now in this, what is our problem statement? Our problem statement says improve water yield, which is basically a recovery rate in the terminology from the RO equipment. Now I have just I have just simplified the constraints. There are more constraints than this. So some of the constraints is your feed water, your water flux, your rate basically at which it goes to and permeate, your pressure vessel, pH tolerance. These different constraints are basically our modeling parameters. These constraints will have an impact on our yield. So for these constraints, what we are trying to do, we are trying to build an objective function where we are saying that each constraint has some weight coefficients. Now, when we talk about these constraints into weight coefficients, group up, so that becomes your objective function. So we are saying that increase your objective function, increase your yield subject to these constraints, which basically mathematically I will take you in the next slide. But please understand that this is very important. How do you put your objective function? Because based on that, we have to take a decision. Either want to maximize your objective function or minimize your objective function. In the case, let's take a case where you're talking about a lead time. So in terms of a lead time, your objective function will be your minimize your lead time. But in our case, where we want to increase the efficiency, the objective function is to increase. And that is one basic important thing in the optimization. The second thing important is talking about all the constraints. Finding the ranges of those constraints, how exactly those constraints are fitting, what are their weight coefficients of those constraints. And these constraints should be greater than equal to 0. They are basically the positive things. There are different approaches for doing this optimization techniques like operations research, Bayesian, etc. But I will be talking about just the basic fundamental block of the optimization. Shashank, can you please go to the next slide? Thank you. Let's look into the canonical form of optimization modeling. What we see here. So we see on the left hand side, so we have an objective function which is C transpose X, which was basically our yield, subject to Ax less than equal to B, which are the different constraints, and X greater than equal to 0, which are our basically the non-negative constraints. What exactly X represents? The X represents the vector of variables which needs to be determined. C and B are the vectors of known coefficients. A is a known matrix of coefficients, and dot product T is the matrix transpose. The expression to be maximized is called the objective function, which I have told you, which we want to do it. And the inequalities are your constraints. So these inequalities will form your polygon, which you are seeing on the left-hand side. So what I'm trying to do in the left-hand side, each line represents one specific constraint. When all these constraints have a minimal, a lower level and an upper level, these constraints will create an polygon. Your optimal solution will lie inside that polygon, and that's what we are saying, the optimal solution. That is the optimal solution region. Now that is what we want to find out in a mathematical manner. Now, instead of from this 2-dimension, if I take you to the 3-dimensional space, think about a sphere. On this sphere, you have the different lines. It could be, and these lines are basically your constraints. And then these constraints join together. And if you put a tangent on these constraints, that will give you the optimized solution. So this is just a basic foundational thing. I'm not going into detail about your Bayesian optimization or any other operational research or linear optimization technique. But if you are very much clear about how do you put your constraint, how do you build, how do you define your equation, what are your decision variables, what are your constraints, is your objective function is to maximize or minimize, if you can put that into the mathematical equation, then it becomes much easier to solve that. Otherwise, even if you apply just a basic algorithm or formula, you may not be able to find the right result. Shashank, can you please go to next slide? Now, this is just for an illustrative purpose, is that here what you see is different constraints we're having different ranges. And when we run this, churn it out in our optimization equation, all these variables will have some different value. Please don't go into the specific number. They're just for illustrative purpose, but this is what is the output expected. Now, what are we having? Initially, we were having some kind of an data, which were called the baseline data. Now we are having the optimal result. But guys, do you think, and the delta between this is the value benefit. For any project, it is very much important to calculate the value benefit. If you are not getting a value benefit from that particular project, it just turns out to be an academic exercise. So from industry perspective, please understand what are your business metrics, what are your mathematical metrics, how are they related. So if I am say is that in this particular problem, my yield, which is basically, if I have to relate my financial, is the cost of per liter of water purchase. And if I'm saying that if I'm increasing my efficiency by 5% or by 1%, means you can get maximum amount of water. You have increased the water the pure water level by the same amount of your raw water, and that delta will get into translated into the cost of water procured, which is basically a saving for the organization. So when you talk about the mathematical in data science, it is also important to understand the problem statement, which Shashank has talked in the beginning, is the how do you do the model the problem. It is also important to think about the value analysis, the value benefit that you get out from that particular project, as which are these are basically the different dimensions, different axes of your data science project. One is your problem, understanding the problem statement, solving the problem statement using your data science, and then getting into the value benefits. Next slide, please. Yeah. So now this is before we come to the conclusion, let's understand and key important things. What as a data science practitioner we should do it. The data democratization. This is very important. Your data should be available for all people and everyone in the organization, and they should be able to take their decision. Now, what does it mean? How can you do it? It means that there should be a process of data foundation. There should be a process of your data, getting the data warehousing, diagnostic reports, descriptive analysis. Things should be mapped together. It should not happen that one of the SBU, that all the SBUs are doing their own individual forecasting. The SBUs should work together in a cohesion, and then the forecasting should be a centralized forecasting, because that is what the value you can get out from the system. If suppose a finance does a forecasting on how many bottles of water is sold, and if commercial or sales or supply does a forecasting, this will not be helpful because they are looking from their own SBU's data set. We need to merge that, we need to link that data set and come up on a standard process. The same thing goes on your descriptive reports, on your visualization reports, which is very important. Data science is an essential differentiator. Once we have fixed our data issue, once we have fixed our data foundation, your integration of the different systems, existing systems, legacy systems, upstream, downstream systems, we can bring the data science, which basically gives you the solution in a non-conventional manner. So there are different techniques of analytics. So some in those techniques, basically, if we have to find the core information, we can definitely go and use data science. We can use the different mathematical models to extract the insights. Now, whatever we were discussing till now is more about how you solve the problem. But once we know that what exactly is the recommendation, how are you going to implement it? And that's where the and most important thing is change management and sponsorship. Whenever we work or whenever you are working, please make sure that there is a specific buy-in from your SBU owners, from the business leaders in terms of the sponsorship, and there is an acceptance, there is a thought process about change management. What it means, suppose in my water, the example I gave is that I come and says that, look, you are running at pH 5, but you should run at pH 4. Now, if I give this recommendation and if they don't implement it, whatever the exercise I did, it remains academic, may not be beneficial from an industry perspective. That's where those people should, the business should be onboarded from very much beginning. They should be a part of it. They should be have a partnership. And then in the end, we have to work together to find the action items, that what are the different actions you need to do. You need to change these pipelines. You need to change these sources, these systems, so that the proper alignment is done, and then only whatever the recommendation is done by data science will be beneficial to the business, which everybody wants. Now, these couple of points what we discussed earlier were more from the organization perspective. As an individual, how is it going to help you? There is a specific question is that, please, they should be always thinking about the value factor, which I just gave you an example before. If I am doing a project, what is the value benefit? Give you an example. If I'm doing an yield project, what is the value benefit? Let's say I'm saving X percentage from my optimization, turns out to be Y liters of water could be saved. Y liter of water has Z cost, and that is your Z value saved. Now also think in one more level from a data science perspective. You are using linear regression. we can use any other different kinds of an equation. Now think about from the system perspective. You have a small data set. Is it good to run on the Spark system, or is it good to run on your on any VM system? What is the cost implication? Whenever we write a code, it is very important to think about the cost of your, this cost is not the monetary cost, this cost is the optimization cost, this is the resource cost. Again, not in the financial terms, but the cost in terms of the usage terms. So when how many bytes of RAM are you using? Should I go with the if loop, or should I go with a for loop, or should I go with a while loop? What is the right strategy to write it? What kind of variable declaration should I do? What kind of an documentation I am doing when I am writing the code? And that is the next point, is that to become a successful in data science, please build a strong foundations in probability and statistics. Probability and statistics are the basic foundation thing. If I ask you a question, is that I have a 5 ball, 2 red and 3 black. If you ask you to select one ball as a black, what it is probability? This should be the answer. The answer, if it is not given, then it means that it's very difficult to go into the and understand more deep concepts about the data science, machine learning, and AI. So please work on the basic foundation thing about the probability and statistics. When you look about from a supply chain perspective, design of experiment plays a vital role, which is basically tells you. So if I'm talking about a destructive experiment, suppose NASA wants to conduct an experiment, launch a rocket. Can they create 2, 3 rockets and can go into a destruction? May not be. And that's where they have to go into and find that what is the right combination of the parameters. So if I'm having, let's say, a pH at 5 level, my temperature at 20 degrees Celsius, is this the right combination? Or if there's another combination, because based on those combination, we will be conducting the experiments. And then once we get those experiment data, we'll be doing different analysis to come up and say, state whether this analysis experiment is successful or not. And then again, operations research, which basically which talks to you about the optimization concepts. There should be an algorithmic thought process. We should think about from the mathematical background process. We should think about we should not always jump on the high density function. We should not always jump on that. Look, I have a problem and let's start using a neural network. Guys, can we look into a linear regression? Can we look into a logistic regression? Why not? Let's try to simplify, because all these things will have a cost involved in the infrastructure as well as the execution time. The problem modeling, which Shashank had explained in the beginning, is another important thing when you're talking about the data science. There should be a translation understanding from the business side to the mathematical side, and then based on that, only we will be able to put the right equations. And then the application of best practices in coding, what the example I was giving is like, should I use if for, or what should be the variable declaration? Should it be like a camel case? Should it be just like XYZ? Should it be some kind of an prefixes, suffixes? And in database, how we are going to store the table, what is the primary key composition, the foreign key entity relationship composition, all those things understanding should be a part of a data science. So in data science, it is basically a package solution where we should be able to understand the business concepts, we should think about the financial benefit, we should think about the problem modeling, which is the most important thing, and the another critical part is probability and statistics. With this, we would like to conclude our session. If we have any question answer, Shashank, can you go to
Thank
the
you so
first?
much, Kshitij, for the detailed explanation.
My
So
pleasure.
we will be starting with the Q&A round now. And please feel free to post your questions in the chat window, and we'll be picking up all the questions related to this topic during this webinar itself. So I have received the first question from Prashant, and Prashant has actually asked this question for Shashank. He says, "Hi Shashank, I have 6 years of experience in CPG background, currently doing DSBA program with Great Learning. How can I best position myself and best pursue a career in analytics, consumer intelligence for CPG domain?"
So that's a great question here. So see, you already have a one good advantage that you have is a domain experience in the FMCG. Now, what I would suggest, you build, as Kshitij suggested, like you build some strong foundations in, probability statistics, linear algebra for that matter, because that helps you to, get the foundational understanding of the algorithm that you are going to apply. So it's, again, it's an iterative, it's an experimentation. Be open. You have to, because this field is evolving every day. Every day you have, some new implementation, some new algorithms, things like that. So you have to, be open to reading a lot, learning a lot, experimenting a lot. And in the FMCG domain, like I had showed, like there are problems, from manufacturing till consumer side. There are a lot of problems where you can apply data science. And to switch over, if I would say, like use your domain knowledge to experience, because that's where you will be in the best position to, translate the business problem into the actual analytical or a mathematical problem. And then, so work on your coding skills, work on your problem modeling skills, you're good to go.
Thanks, Shashank. The next question is kind of similar, and it is coming from Abhay. And it says, I have worked into branding like pre-launch and post-launch of new products in FMCG. I'm also doing DSBA from Great Learning. I would like to know how I can start my journey again in FMCG in a data science profile.
So I think, yeah, I mean, there are, like, a lot of open, positions all around. And again, the thing is like quite similar. You have the domain experience where, you can leverage to the most critical part here is, modeling the problem. And that's where, if you build strong foundations in the data science algorithm, and that comes from practice, the more you practice, the more you kind of try to solve the problems. So, and one thing could be like, with your kind of experience in the FMCG domain already, you can think now you already know, what kind of problems, your probably your companies or things are facing. Try to, uh, try to think like, when you're learning with the great learning, whatever the course that you're doing, try to now think like, if I had to solve this from a data science way, how would I approach it? How would I model the problem? And the first step I would suggest, I mean, try internally. If there's an internal data science team in your company, try to make a kind of a switch, or try to talk to them, try to understand how, what kind of problems they're solving. And you can even bring your own problem, that okay, this is the problem and this is how I think I could solve. And try to build a rapport, try to, because internal switch is much easier than, looking outside. So I hope I answered that question.
Thanks, Shashank. The next question is from Parth, and he says, are there any supply chain analyst job roles for freshers? And what technical skills should I build to get into those fields?
Yeah, from a role perspective, there would be always many roles in the supply chain data science perspective. Because if you think about it, and for that, you need to have the understanding of the domain, which is the supply chain, as well as the data science perspective. Now, these days, what we see is that it is basically a mixture of a domain data scientist, be it your finance data scientist or be it a supply data scientist. If you want to go further in the supply chain data scientist, try to solve the problem mostly in terms of prediction, in terms of an optimization. You can start you can start with the basics. You can look on the Google, what are the different optimization problem. You take about a network optimization. Let's say if I have to put the water pipelines, or I have to put any SGG pipelines, then what is the minimum path that I need to take it? That is a kind of an example. If I have to send one courier, one parcel from location A to location B using multimodal, what are the different options of the modes available? What are their costs? How do you get the best equation out of it? If I have to set, if I have to do the prediction, is that after which particular date my machine will stop working? That is again kind of a prediction part. Now, how can you learn the supply chain? There are so many informations, so many courses available online. You can start going into the basics of supply chain, and then try to always think about from the problem perspective, and then try to model that problem, because the modeling the business problem into a mathematical problem is the crux of a success of any data science project.
Thank you so much, Kshitij. So the next question comes from Shikhar, and he says, any thoughts on the use of graphic modeling in FMCG?
I take that question, Chudich.
Yeah, go ahead, please.
Cool. So, I mean, there are like, I mean, if I say the graph modeling, so again, something like I'll give an example from marketing perspective, and maybe Kshitij, if you can
Yep.
give an example from supply. So one of the example use case could be, finding the influencers. So, finding the influencers of your brand, and then creating a strategy. So how do you discover that kind of things? So this is where you can use the graph based modeling approaches, or maybe another could be finding the the cluster of your top selling stores and your top selling. So in a typical FMCG, you have distributor and retailer network. Okay, so in that, finding the top clusters of the distributor networks, the retailer networks, and things like that. So those kind from the commercial and the marketing angle. Kshitij, you may want to add something
Yes.
on the
So
supply.
let me give you an example. Suppose you want, there's a pen, right? This is a pen. There are so many components attached to this pen. Now, these components come from different locations. Basically, in supply chain world, we call it a bill of material. Now, if you want to think about how do you optimize your cost of from a bill of material perspective, this can be easily modeled in a graph database where you can have different kinds of nodes, vertices linked to, and you can build up different relationship, and then you can use that analogy, that equation to help it. In addition to this, I will give you one example in the terms of the COVID, and there's a research paper available on the net by some organization. So basically, they're saying is that how can you track the that how do you identify the people, the primary contact? So there are many ways. So they found that okay, who all in the store, what was a credit card used in that credit card time, what is the time, then for that time which is the POS, in that POS which are the other credit cards, who are those people, what are their mobile information. All these data comes into a graphical representation, and then we can calculate, we can find that who is the next primary contact. So there are many ideas, there are many cases where graph database can help us. Again, if you think about the social media, the LinkedIn, all these are basically the graph database. The earlier example what I was talking about, that how do you integrate the SBUs from a supply side to a finance side, we can build this on terms of the graph database.
Thank you so much, Kshitij and Shashank, for the wonderful answer. So I was just checking through the questions. I think the questions are majorly repeating now. So anyone who has joined late, please feel free to go through the recording once again. The recording will be available, so you can check those questions. So that brings us to the end of this discussion. And thank you so much, everyone, for joining with us today. And thank you so much, Shashank and Kshitij, for sharing your thoughts with us. For everyone, for more insightful sessions like these, please do subscribe to Great Learning so that you are always updated with the latest industry trends and discussion. So thank you so much and have a great day. See you next time.
Thank you.
Thank
Yeah.
you. Equal
Bye bye.
pleasure. Bye bye.